Today we're going to complete a classwork activity together on dilations. This paper can be found in the notes folder, so be sure to print this off first, then come back to this video and follow along, pausing as needed. So the directions, we're going to find the coordinates of the vertices of each figure after a dilation with the given scale factor k. So in each problem we have a scale factor, and then graph the image of the dilation. So remember, to find the new vertex, remember one vertex and multiple, if you have multiple vertex, it's vertices. So to find it, we're going to multiply the scale factor k times each value. So for example, J prime, take the x value, -4 times 1/2, and we have -2. And -1 times 1/2 is -1/2. Let's continue finding all the vertices and then we will graph it. So k prime would be 0 times 1/2 is 0, and 4 times 1/2 is 2, and L prime, -4 times 1/2 is -2, and -2 times 1/2 is -1. So remember, when we graph, you're going to start at the origin, and the first value is always x. It's always x comma y. So since it's -2, we will go to the left 2. Make sure you label that J prime. It needs to have the prime mark. K prime is 0, 2, so 0 does not go left or right, but +2 goes up on the y value, and we're going to make sure we label that K prime. And then L prime is -2, -1, so first value is x, go to the left for -2, and down for -1, label that L prime. So we finish off by drawing our triangle, and there we go. You can see that our triangle is half the original size. So at this time, I would like for you to complete number 2 on your own. Go ahead and do that now. I'm going to take away this to give you time to do that. Okay, if you have not finished finding all the ordered pairs, please pause the video here. But checking yourself, if you've already finished, these should be your vertices for your new image. So take the time now to graph it. Okay, you should not have finished graphing just yet, so please pause the video, and then you can compare. Here is the finished problem number 2 graphed. Make sure that all of your vertices are labeled with the prime mark. Now go on to number 3. Please pause the video here and complete number 3 on your own. Here are my vertices for number 3, making sure to write the prime. And again, pause the video again to complete the graph on your own. So you should pause the video if you still have not finished. You shouldn't have finished so quickly, so pause it, and then you can check. Here's the graph and the vertices. You can see the scale factor is 1/3, so our new rectangle is 1/3 the size of the original pre-image. You can check this because counting across 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 9 across. 1, 2, 3 for our image going across. 3 is 1/3 of 9, or in other words, 9 divided by 3 is 3. So that's 1/3 the size. Now pause the video again to complete the vertices for number 4. Here are the vertices for our image. Remember, multiplying the scale factor times every value. Pause again to complete the graph. So please make sure you pause if you didn't finish. Otherwise, here is the graph for number 4. The scale factor is 3. That means 3 times as large. This new triangle, A prime, B prime, C prime, is 3 times as large as the pre-image. Okay, let's go ahead to number 5. We have photos. Keisha used a photo that measured 4 inches by 6 inches to make a copy that measured 8 inches by 12 inches. So take either value you want, the first or the second value, it makes no difference. I'm going to choose the second value in each one. They're both in inches. So you have to decide, is your scale factor with these numbers 6/12 or 12/6? So if I think about this, I know if I go from 4/6 to 8/12, it's getting larger. That means I need a scale factor greater than 1. 6/12 is 1/2. That's less than 1. I don't want that. Instead, 12 divided by 6 is 2. This is the scale factor that we want. The scale factor is 2. It's getting twice as large. So that was easy to see with these numbers. 8 is twice as much as 4, and 12 is twice as much as 6. Go on, read number 6 on your own, and complete that one on your own, please. Okay, so pause the video if you have not finished. Otherwise, I have the scale factor. I chose not to use the first value because of the decimal. I have 2 feet and 50 feet. So my scale factor is either 2/50 or 50/2. I know that in this model, we're getting smaller. If the original court is 94 feet long and by 50 feet wide, the new image, the new model, is smaller. So I would not use a scale factor greater than 1. I would use the scale factor less than 1. And simplifying, my scale factor is 1/25. That means if you take the original value, divide by 25, that's the new image. So go ahead and complete number 7 on your own. Please make sure you pay attention to labels. Okay, so now number 7, if you did not pick up on this, this is his great room. On the blueprint is inches, but the actual room is in feet. You cannot compare these values. So what I did was I multiplied by 12, since there are 12 inches in a foot, and I got the actual room is 216 inches by 240 inches. For this particular one, I'm choosing the second value again. We have 5 inches, we have 240 inches. So which is the scale factor? It's either going to be 5 over 240 or 240 over 5. So which is it? Well, if you're going from blueprints on paper to building an actual room, you're getting bigger. You need a scale factor greater than 1. It will not be this one. It has to be this one here, which gives me a scale factor of 48. The actual room is going to be 48 times as big as the original paper drawings.